Thank you very much for having me here today. My name is Samuel. I'm from the Soil and Water Conservation Bureau. So today I'm going to share some experiences. The Bureau deal with landslide disasters in the past decades. So this slide shows the organization chart of the Soil and Water Conservation Bureau. Originally, we are the engineering unit. So we do a lot of engineering construction works in the mountain areas. And recently, we deal with the landslide debris flow disaster prevention works. We also have some rural village regeneration works we are doing. So we got several divisions and we got 6 branch offices around Taiwan. So from the right-hand side, you can see that over 70% of the land belongs to the slopeland. Besides, we have frequent typhoons and earthquakes. That's why we have a lot of sediment-related slopeland disasters every year. So here are some pictures and a video about the debris flow disasters, which is a kind of landslide. Those kind of debris flow disasters usually caused by different typhoons, which bring some torrential rains. And after the video was televised to the public in 1996, people here aware of the severity of debris flow disasters. So this slide shows the framework, how we deal with the debris flow disasters. Usually, when we are doing the hazard assessment about debris flow disasters, we will ask ourselves 3 questions: where, when, and how big. So where are the debris flows? After more than 10 years investigation in the field, we have more than 1,700 potential debris flow creeks, which means those creeks are prone to debris flow disasters. And each creek has the downstream affected area, which is usually the fan areas. People who live there were prone to debris flow disasters. So every year we work with the local government to come up with the inventory of those people who live there. It's about 50,000 people. So from the left-hand side, traditionally, we use a lot of engineering construction, try to prevent from happening about the debris flows. But then we found out that those kind of engineering construction has a limitation. So recently, the government turned to some software measures, such as the relocation of the local people, restriction of the land use, but people don't happy about that. They usually will protest against those measures because the price of the land will going down. So recently, for the government in Taiwan can do is that during the emergency when typhoon comes, we evacuate people to the safety shelters. So if we want to evacuate people, then we have to know when the debris flow will come. So before that, we have to set up some kind of rainfall-based early warning system to issue the warning for the evacuation of the local government as well as the local people. So every time during the emergency when typhoon comes, so we just establish the debris flow emergency operation task force in our bureau. So we have a web-based decision support system, which is a cooperation with Professor Zhou and逢甲University. Then we received hundreds of the real-time rainfall data from different resources, such as the automatic rain gauges all around Taiwan, more than 500. and we set up some on-site monitoring stations like the pictures you can see. From the right-hand side, we use different kinds of sensors to detect the occurrence of debris flow and issue the warning to the local people. We also try to train the local people and establish their community into so-called disaster-resistant communities. People are well organized. They know what to do. They know their jobs during the emergency. So those kind of communities has the right-hand side, the black one. It's a simplified rain gauge, which can detect the real-time rainfall and send back to our headquarters in our system. After calculation, then we issue the real-time warnings. We also work with the US NOAA and the Central Weather Bureau Water Resources Agency. We assemble using different kinds of radar system to receive all kinds of reflection from the radar about the rainfall prediction. That's very important for us to issue the debris flow warnings. So from the warning stages about debris flows, usually we have two stages. When the predict rainfall is over the threshold in certain area, then we issue the yellow warning for persuasive evacuation. So when this area, the real rainfall is over the threshold, then we issue the red warning for the mandatory evacuation. So people just, according to the act, they have to follow this instruction to be evacuated by the local governments. So from 2004, we deployed this kind of debris flow disaster prevention system. And let's take a look at the red line, which is the debris flow casualties and wounded number versus the typhoon, the whole events. We find out after we deployed this kind of system about the evacuation plan and early warning system, the ratio is getting lower and lower, which means this kind of system has been proved effective about saving lives. But in 2009, we encountered another different kinds of landslides, not only debris flow, but deep city landslide. There's an event during the Typhoon Morak, which is the most devastating typhoon ever hit Taiwan. In southern part of Taiwan, a village called Xiaolin Village, when the deep city landslide occurred, it covered about half of the village and then formed a temporary dam. About 40 minutes later, the dam broke, and then the floods just flushed away the other half of the village and causing more than 450 casualties in one event. Those kind of events just shocked our whole countries. So after that, the Soil and Water Conservation Bureau tried to come up with a program which named Comprehensive Program of the Large-Scale Landslide Hazard Mitigation under the Climate Change Impact. So this year is 2021. So this is the second stage of our program to deal with the large-scale landslide. The total budget is about $400 million US, and we try to deal with at least 100 sites prone to large-scale landslides. From this picture, the left-hand side, you can see the Xiaolin Village before the large-scale landslide. The right-hand side is after the large-scale landslide. Nothing left there. Everything is just flushed away. So this kind of program based on the identification of the potential areas prone to large-scale landslide, we use the LiDAR techniques try to solve this problem. The LiDAR techniques is the light detection and ranging. It is a very common ways to make the high resolution DEM, which is the digital elevation model. On the right hand side, usually we use the airborne LiDAR. And from the left hand side, the pictures, this LiDAR DEM can remove all the vegetation and reveal all the geological and geomorphic features about the deep city landslide, like the pictures in the center. So whenever we find out this kind of characteristics of the large scale landslide, then we can zone it, and like the hazard mapping method, try to identify those areas prone to the disasters. So after that, we do the risk analysis. We consider different kinds of degrees, different kinds of indexes about the activity, about the people who live there, about the hydrological and the geological conditions, and we have our own priority about these potential areas. So we just put the money to different places through this priority about the engineering constructions or some evacuation plans, or try to train the local people become the resilient communities. We borrow our debris flow hazard mitigation experiences, try to put them into the field to solve the large-scale landslide, and we do a lot of different kinds of monitorings. Such as we use the INSAR techniques, which is the satellite radar reflection, try to detect the surface deformation, especially the minor deformation about the ground. So subsidence is the places we are trying to look at using the INSAR techniques. We also put different kinds of surface displacement monitoring system. For example, the GPS system, extensometer, we compare this displacement with the rainfall data, try to find out the behavior of the large-scale landslide. So from the left-hand side, we do some engineering construction. For example, the most commonly used engineering construction is the groundwater collection well. When we dig the well in the slope, then we collect the water of the underground, and from the red circle, after the well construction, the groundwater table just decreased a lot, which means the driving force decreased a lot. So the slope become more stable than before. So this is the measures we are doing right now. So the last part I want to say is that from the past 2 years, we have some experiences sharing about the debris flow disaster mitigation about Taiwan. So we attend the OGC Disaster Resilient Pilot User Guide. We have the landslide early response and evacuation under limited bandwidths. We share our experiences dealing with the landslide, especially focus on the debris flow disasters. So in the future, we are willing to share more and more our experiences dealing with not only the debris flow, but also large-scale landslide or even the shallow landslides. We would like to experiences sharing about to those communities about OGC families. So we also like to learn some experiences from other communities. So we hope we can continue to devote ourselves to this community. That's the end of my talk. Thank you.